Assalamu alaikum everyone. This is lecture 20 for CS116 object oriented programming. So let's get started. When we started this course, we during first 4 or 5 lectures we discussed some most common concepts that are associated with object oriented programming, and there we discussed them rather theoretically, and later we saw how we can implement those concepts in Python, or what kind of support does Python provide for implementation of all those concepts. So now we are in the 7th week and we have completed almost all those uh, uh, concepts, or we have seen how we can implement all those concepts in Python. We have seen how we can create objects and classes in Python. We are familiar with the concept of encapsulation and data hiding. We also know the syntax for inheritance in Python, association, polymorphism, and all of its types, method overriding, operator overloading, abstract classes, and method overloading is not required in Python, but there is a form called duck typing, which already provides a support like method overloading. So we have discussed all this. Then we also learned some related concepts along the way, like decorators and properties. So we are almost done with the major features of object-oriented programming. One last concept that is very important in object-oriented world is of exceptions. So in today's session, we'll start exceptions. What we learn today, we'll see what are exceptions, and then we'll see how we can handle exceptions. This is the simplest definition for exceptions. Exceptions are special objects which are used to flag exceptional conditions, especially errors. So there are two main points in this statement. First is that exceptions are also a kind of objects. Like we know everything in Python is an object, so exceptions are also objects, and these objects are created when your code encounters any exceptional conditions. Most of the times, almost all of the times, these conditions, they are due to some errors. So in many literatures, these two terms, exceptions and errors, they are used uh, interchangeably. Let's see some examples of errors. In fact, you guys are familiar with all these errors. Let's just list them here. First is this: attempting to read past the end of the file. That means you are trying to read a file and you keep on executing the read command even after the file has finished. So your program will naturally raise an error and it will stop, and that will be related to this file. That error will be related to file reading. Then this means that you are trying to index a list using an index number which is beyond the range. Let's suppose you are defining a list having only 4 elements and you are trying to access an element at index 9. So obviously that's out of bound. That also causes error and it causes your program to stop. Then let's suppose you are asking user for an integer, and then you typecast whatever user inputs, you just typecast it to integer, but the user, instead of entering any integer, enters some string or some non-number value. So then also your program crashes and it prints that error message and it stops. And this can also happen like you are trying to print a variable that you have not defined, or you are trying to access an object which you have not defined or have not assigned any value to. So these are few examples of error conditions. That mean in all these conditions, what Python does, it raises exceptions, or it creates an exception object and it uses that object to flag that exceptional condition or flag that error. So exceptions represent a standard way to deal with runtime errors. Python provides a comprehensive uniform exception handling framework. Now, what I mean by this, what's happening up till now, whenever an error occurs, a runtime error occurs, what happens? Your program simply terminates and Python prints some appropriate, error message. So that printing of error message is part of this exception handling framework. What else does it provide? it provides us tools by which we can stop our program from being terminated when some runtime errors occur, and we can handle those errors by ourselves in the code instead. Like there are two ways you can leave your errors for Python so that it can print its own appropriate messages, and in that case it simply terminates your program. But there is an alternate way too. You can stop your program from being terminated unexpectedly, and you can handle those errors by yourselves. So that's what exception handling framework provides. So we'll explore that framework in this lecture and in the next lecture. So if we are able to use this framework efficiently, we can make our code logically cleaner and less prone to programming errors. Like, you can become a better programmer if you know how to handle these exceptions. So that means that there must be some built-in exceptions. So we have some built-in exception classes. As I told you, that exceptions are objects too. So that means that there must be some classes behind them providing some blueprint for those objects. So there are some built-in classes too, and then we can define our own classes too. And Python provides a proper syntax for defining these exceptions so that all exceptions, user-defined exceptions as well as built-in exceptions, they are compatible with each other. We have already seen some exceptions without knowing the name. Like we know what Python prints when some error occurs, but now we know that those errors, they are called exceptions. So let's recall that first. For example, I print this statement. You can see there is a syntax error in this statement. I'm not using that opening bracket in that print function. So if you run this, actually I'm running it on Python shell. So if you run it, you'll get this message. Missing parentheses in call to print. Did you mean print hello world? Like it is suggesting the correct format. And there is, at the start, it's written syntax error. So this syntax error is actually an exception class, right? Similarly, Python has different classes for different types of error. So let me show you a small list of some common exception classes. First one is syntax error. I just showed you this. It means whenever this class says object is created or this type of error is shown at Python's shell, that means that we are using some wrong syntax in the code. Then we can have an attribute error if the object does not contain the specified instance variable or method. Like you are calling a method which does not exist in that particular class. That raises attribute error. Import error, when you are trying to import a module which does not exist in your library, like you had to install it from somewhere else and you did not do it, so program raises the import error. Index error, when index is out of range. This is the one that I showed you an example as well. Like you are providing an index which is not part of a list or a tuple or a string. Key error, specified key does not appear in a dictionary. So this one is related to the dictionary container. Okay, when Python is not able to find some variable name, it raises this kind of error, name error. Type error, when operation or function applied to an appropriate type, like it does not work that way and you are trying to use it with the wrong type. Value error, one of the most common type of error, like you are entering a value which is not appropriate for the code. Like you are not entering an integer when an integer is expected in the code. So that will raise value error. Zero division error. This is one of the very famous type of errors in computer world. Whenever you try to divide a value by zero, this error is raised because we know we cannot divide by zero. That produces an infinite value. So this is a very common error that appears in mathematical calculations. So the point is, these all types of errors that we have listed here, they are all different classes defined in Python. Syntax error is a class, attribute error is a class, and so on, right? So Python provides specific classes to handle some specific errors. And then if you can use all these classes and you can handle these errors by yourselves, or you can define your own classes as well. Like you can add up to this hierarchy. So Python maintains a complete hierarchy of exception classes at the backend. Let me show you a glimpse. This is the base exception class, the main exception class from which all exception classes are derived. Then there is one more important class, and that is called exception, which is derived from this base exception class. And all the exceptions that I showed you on the previous slide, they are derived from this exception class. So they are placed here in the hierarchy, one way or the other. Like index error is not direct descendant of exception, but exception lookup error is a child of exception, and index error is derived from lookup error. So all those built-in classes, most of those built-in classes, they are derived from this exception class. Then if you are defining your own exception class, that means you will be placing your class here, most probably here, right? So that means when we'll define our exception classes, most probably in the next lecture, we'll have to derive those classes from this base class exception. And then there are some other classes too, which are directly derived from this base exception class. I'm not going into the detail of these classes. I'm just trying to make sense that how this hierarchy has been implemented. And one last thing is that we all know that there is a base class in Python from which all other classes are derived. I hope most of you have guessed that class, and that is object. So base exception is derived from this object class. Okay, now let's formalize this exceptional control flow. So what happens when an exception occurs? The normal execution of your program is interrupted or stopped, and then a special type of execution occurs, which is called exceptional control flow. And this exceptional control flow can be decided by the user himself, or if not, then Python has some automatic mechanisms for handling it. So if you are letting Python handle your exception, so what does it do? It uses its exception classes, built-in exception classes, some of which we just saw on the previous slides. And what it does, it simply terminates your program or stops your program, and it prints its error message on the shell. And that error message is obviously produced by these exception classes or objects that Python builds from these exception classes. And one good thing about this, about these error messages, is that it does not print a single error message. In fact, it prints a whole traceback. Like if you are calling nested function and error occurs somewhere inside that, hierarchy or inside that nest, so it prints a traceback which can help you locate your error. So next time when an error occurs, you just see that traceback and try to make sense out of it, like how it prints, the whole hierarchy from like from the current point where the error occurs up to the main program from where you started. So this is one way of handling exception. Like you are not actually handling exception, you are just leaving it to Python. But if you don't want your program to terminate, what you can do, you can handle these errors or exceptions by yourselves. And for that, Python provides statements like try except statement, and we can use these statements to handle those exceptions. So let's see how these statements work. So let's see the syntax for these two statements. Now these two terms, try except, they have different names in different languages. Like some languages use throw and catch words instead of try and except. So here we'll see try and except. Actually, these are the keywords. So we have a try block in our code. You just use this keyword try followed by a colon, and then you include some code here, and then you can define an except block. And in except block, you can also define some other code. And then there is a third piece of code. So what you do, the code in which you are expecting an error, you place it in the try block. right? So code block 1, it contains the code that can cause error, and the except block, it contains the handler code for that error. Like if that error occurs, we'll catch it and we'll handle it. So how we'll handle it, that code will be specified in block 2. So how it's executed? uh, First of all, code block 1 will be executed, or the try block is executed, or you can say that Python starts executing your code from the try block. Okay, so if some error occurs in that try block, we switch to the except block. Like let's suppose there are 5 lines in try block, and the error occurs at the second line, then we will not execute the remaining 3 lines. Instead, we'll instantly switch to the except block, right? So if error occurs, code block 2 starts executing, and code block 3 is a general block which is executed in any case. So that means if your code runs normally without any error or exception, then code block 1 will be executed, and then code block 3 will be executed. But if your code produces some error, then code block 1 will be executed up to the point where error occurs. Then code block 2 will be executed, and code block 3, since it is unintended block, it will be executed in any case, right? So let's see an example. Now in this example, I'm writing a simple program in which I'll input an amount of money from the user, and then I'll input number of sharers, and I'll simply print the amount each sharer gets. So I hope you all know what I'll do. I'll simply divide the amount of money by the number of sharers, and I'll get that fair share each sharer gets, right? So first, let's not handle the error, and let the default Python handler do the job. So here's the code. First of all, I'm inputting this value, right? And since this amount is expected to be integer or float, let's suppose integer, I'm taking it to be integer. So I'm typecasting the input to integer, and I'm assigning it to this variable name amount. And then same way, I'm taking the number of sharers as input, and this has to be integer, so I'm again typecasting it to integer. And this is what I print. I simply divide that amount by sharers and I print it on a screen. Each one will get rupees, X. So you see, it's a very, very simple code, but what possible errors could it produce? Let's suppose you are not entering any integer value, because you see in both the statements, in first 2 statements, you are typecasting the value that has been returned by the input function to integer. So if the user enters an integer, that is absolutely fine. But if the user does not enter any, integer, then it will raise error. So if I don't handle it, what happens? Python will terminate your program and it will simply print an error message. So let's see that. Now, if I run this code, it will prompt me to enter an amount. I'm being creative this time, so I entered the amount this way, 200. So actually it's an amount, but it is not entered the way the program was expecting it to. It was actually expecting some integer. So what will happen? It will raise an exception here, and that exception will be handled by Python itself. And what Python will do, it will print some error message to help us locate this error. So this is the error message that Python will print. You see, it's showing a traceback, but that error occurred in the main program only, so that it's not a long traceback, and it's showing value error. That means that we entered the wrong value. It was expecting some integer value base 10, but we are entering the wrong value. Now let's implement the same thing using try except block. Now in try block, what I'll place my code in which I'm expecting some error. So this is my code, and here value error may occur. So I'm just placing this code in try block. And in except block, what I place the code which I want to execute when an exception occurs. So now what will happen when that exception occurs? The the flow will not go to Python. Python will not print its own error message. Instead, my error message will be printed, and this is that message, error message or whatever I want to do. In case of that exception, I put that code here, and I'm placing this last statement as a general statement. So this will be executed in any case, whether exception occurs or not. Let's see two instances of output, one when exception occurs and the other when no exception occurs. So the first one is the case when no exception occurs. Okay, we were asked to enter a value and we entered a valid value. We entered a valid value for the second input as well. So that means exception did not occur, and there will be no issue. So amount will be divided by sharers and the output will be printed, and that's the output, right? So this is the case when exception doesn't occur. So we saw that try block, it was executed successfully. So that means now except block will not be executed and we'll directly go to that last general statement. So here it is, right? Now the second case is when user enters something unexpected. So let's see this. Now user is entering a string instead of an integer value. So that means as soon as this value is processed, input value is processed by Python, this try block will cause the normal execution to stop. That means now the second statement, that sharers, and that third print statement will not be executed. Instead, the flow will switch to the except block, and in except block we have that print statement, so that will be printed, and after executing the except block, the last general statement will be executed. So the point here is that as soon as the exception occurs, the remaining of the try block is skipped and we directly come to the except block. And if the exception does not occur, then except block is never executed. So up till now we discussed just one type of error, that is the value error. That means that user is entering something which is not an integer. But some other kind of error can also occur in this code. For example, this code is performing a division, amount divided by sharer. So what can happen if the user enters 0 as number of sharers? So this can also raise zero division error, right? So that means that we can have now two types of error, a value error or it could be a zero division error. So up till now what we are doing, there is just one general except block and we are printing a general error message, enter inputs in digits. But if you want to print different messages for different types of error, then that is also possible with this try except block. So let's see an example. Here I'll classify these two errors, like I'll print different messages for these two types of error. So what should I do? There is no change in try block remains the same, but in except block I can specify the type of error. So we know that value error, it's a class or it's an exception class. So if this kind of error occurs, I'm printing this message. And if zero division error occurs, zero division error is also a built-in class of Python. So in that case, I'm printing a different kind of message. And here is my general message. So let's see how it works. This first output shows when value error occurs. Here, see, I'm entering some non-digit value. So it prints that first error message, enter inputs in digit. And then we have that general line. At the end, have a blessed day. And in this second example, let's see if that zero division error occurs. So that will occur if I enter a 0 in the second input, in sharer's input. So first input is valid. In second, I am entering 0. So this is also fine because no value error will be generated. But the third statement, in which I try to divide amount by this 0, that will cause error. So this error has been caught by this zero division error class, and it prints our custom message here. And this is the general message. So we discussed that two types of error can occur in that code, but those were the ones that we could think of. There could be any other runtime error that we are not aware of or we are not expecting in our code. So what we can do for that, we can include a catch-all exception handler, right? and that will be there to handle any unexpected exception. So what we can do for that, try block again remains the same. There are two excepts block from the previous code. The first one is for value error and the second one is for zero division error. And after that, we can add a general except block, right? So that means if that exception raised is not a value error and it's not a zero division error either, then we'll come to this third except block, and this will print some, general statement. And then here is our, have a blessed day statement. Now, I'm not executing this code for you. It's there in the file. You can just go and, play with this and see what kind of messages does it display. In fact, I'm not able to think of any situation in which that third except block executes, but let's see if you are able to. Now, as I told you that exceptions, they are objects. Like there are classes behind them which are serving as blueprints for these objects. So you can also catch these exception of objects and you can manipulate them as you feel like. And for that, we use the as keyword. So let me show you this through that same example. The same try block, it is unchanged. Okay, in except block now I'll try to catch that value exceptions object. So what I have to do, I'll do this, except value error as E. So that means if this value error occurs, that exception will be caught, and that exception object will be linked to this variable name E. So then I can use this E to print that object or see other aspects of that object. So here in this statement, you see I'm trying to make use of that E. So this except block will be entered when user enters some non-integer value, and when it is entered, what I'm doing, I'm just catching that value error object, and now I'm printing my error in a new style, problem with value, and I'm using the information from the object itself. So this is just a way of catching that object. It might be useful in many cases, or you can not use this, or just follow the previous pattern, like print your own message which does not depend on this object. But this is an alternate way, so I just wanted to show you this. Same you can do with the other error. You can use the same name. They don't interfere with each other because only one of them will occur at a time, and then you can print a similar message here. Obviously it will print a different message when the actual error occurs. Okay, you cannot use this as keyword with this general message. So here we are not making any change. Okay, so I'm not again showing you any output. It's there, the code is there in the file, and you can go test it by yourselves. Up till now, we have seen that Python raises exceptions whenever it encounters any unusual condition, especially errors. So if we leave that exception, then Python handles it by itself. Otherwise, we have option to print custom messages also. So but all those errors that were raised or exceptions that were raised, that were done automatically by Python. Now we'll see that we can also raise our own exceptions. Like let's suppose we are checking for an input. Let's suppose we are range checking for an input, and it does not fit the criteria that we asked for. So what we can do, we can raise our own exception. So let's see how we can do that. For that, Python provides this keyword raise. So let's see the syntax first. This is the syntax. Raise is a keyword followed by some exception class name, and then in down brackets you are placing some custom error message. So basically this exception class name, we have to place some exception object here, and that exception class name represents that object. It initializes or instantiates an object, and that is placed here. So it has to be some exception object. It could be of any built-in class, which we have seen so far, so many built-in classes like value error or type error, etc. Or it could be some user-defined class as well, which we have not seen yet, but we'll see that in the next lecture, like how we can create our own exception classes. Now, these round brackets, they contain actually arguments which we are passing to the constructor of that exception class object. So there could be as many arguments as a particular constructor allows, but most commonly we place some error message here, a custom error message, which has to be printed when this exception is raised. So this is the simple syntax. Now these round brackets, they are optional. Like if you do not want any custom message, you can just write that keyword raise followed by exception class name without putting any round brackets. For example, you are taking an input from a user, and you have asked for a positive integer, and the user enters something else. Like let's suppose user enters a negative integer. So what you can do, you can put a check in your code which sees if the entered value is a negative integer, and if that's the case, then you can raise an exception by yourself using this statement. So here raise is a keyword, and I want to raise value error in that case with this specific message, cannot enter a negative value, right? So this will raise the exception, and it can be handled the same way as we had been doing in the previous slides. Like if you just go it uncaught, then what will happen? Python will handle it and it will print its custom message, but it will terminate your program. Or you can handle it by yourself using that except block. Now there are some supplementary points for this keyword raise. If there is no exception built-in class that suits your needs, then generally you can use that main exception class, and you can provide any message that you want there, or you can build your own custom class as well, right? Which as I told you, we learn in the next lecture. Sometimes you catch an exception and then you re-raise another exception, so that is also possible, but I'm not going into that detail or will not show you any example for that. But the only point of telling you this is that you should keep this in mind, that you can always re-raise an exception and you can handle it again somewhere, or you can just leave it for Python to handle it by default. These are two more keywords that can be used with exceptions, try, except, constructs, else, and finally blocks. So let's see what these are. These two blocks, they are optional. Like try except block is complete in itself, but they can be used to provide some additional functionality. Let's see what that functionality is. Else block executes if the statement in try block don't raise an exception. Now I hope you can recall that we use this else block with loops too. So what happened there, we could break a loop anytime using that break statement. So if you are putting an else block below that loop, while loop or for loop, that else block executes if you are coming out of that loop without breaking it. So I hope you remember that concepts. The same thing applies here. The else block gets executed only if the try block is executed completely, because if any exception occurs within this try block, what happens? The rest of the statements in that try block, they are skipped and we come to the except block. So in that case, this else block will not be executed. It will only be executed if no exception is raised and try block reaches completion without any error, right? So where we place it, we place this else statement after all except blocks. So there must be an except block as well, and you place this else statement after that except block. Then we have this finally block. This finally block executes in any case. As we saw previously, that there was a code 3 in try except block, and that code was executed in any case. So you can place that code alternatively in finally block as well. So finally block always executes whether exception is raised or it's not raised, right? So these are rarely used because we know that whatever we place after that try except block, that is always executed. So there are few applications of this finally block. If it's there, it should be placed in the end. Like if the code contains try, except, else, all kinds of blocks, so there we'll place finally block in the end. And usually we place some cleanup code there, which must execute after, in any case. For example, if you are opening a file in try block and then exception occurs and you fail to close it, you can do that in the finally block. Here are a few points that you should keep in mind. This finally block, one important thing about this finally block, as I told you, that we rarely need it in normal context. So one special thing in which you can use it is that it can replace except block. Like these two blocks are optional. Finally block is also optional and except block is also optional. You can use any one of them with your try block. Like you can make try except combination, or you can make try finally combination. So if you do not have anything to do when an exception is raised and you do not want to take any special action, then you can directly come to a finally block as well, right? You can skip writing that except block. So this is one advantage where you can use this finally block. But that means they are optional, but there must be a try block associated with them, and else has to be associated with a try statement or a while statement or for statement, as we had seen before. But in context of exceptions, else has to be supported by try. In fact, try, then except, and then we use else block. So what options or combinations can we have? We can have a try block, then except block, then else block, and then finally block. Like you can have all four blocks in your code. Other option could be you can have a try block, you can have a except block, and then you can have an else block. And third option could be you can have a try block and you can have a finally block, right? So if you're not placing except block, then there is no sense in placing else block either. So a third combination could be that a finally block directly follows the except block. So here in this lecture, we have just discussed these concepts of how to raise an exception and how we can use these else and finally blocks. In the next lecture, we'll see a comprehensive example in which we'll be using all these constructs. Before ending this lecture, let me share an interesting story with you. It is actually related to this exceptional control flow, and it's about the maiden flight of Ariane 5. Ariane 5 was a rocket launched by some European country in 1996, and it exploded in its first flight. So what happened there was, European Space Agency, it spent about billions of dollars and years of research on creation of this rocket known as Ariane 5. And on 4th June 1996, this rocket took its first flight, maiden flight. And within a minute, like in 37th second of its flight, it was exploded. And when they inquired about the reason behind that explosion, the culprit was this exception. Actually, when its software was running, an exception was raised which was not handled properly. The software was trying to convert some float value to integer, and that conversion operation was not successful. It raised an exception, and we know if you don't handle that exception, your program simply terminates and it crashes actually. So that's what happened there. They did not handle that exception, so when it occurred, the program simply crashed, the software closed down, and because of which the computer of that rocket shut down. And after that, the rocket started turning uncontrollably, and then it exploded. So see, this is the cost of a very small, you might think that it's a small error. Like you might not think that handling exception is not that important, but see that error, it cost billions of dollars to European Space Agency. Actually, I took this excerpt from your book. You can find it here in this Perkovich book, and you can also track this on internet. This is what they have got on internet. $370 million for an integer overflow. Like for such a small mistake, like not handling an error, it cost them $370 million. Actually, that rocket carried cargo of 370 million. That amount that was spent on research is a separate head. Only cargo that this rocket was carrying was worth $370 million. So see, sometimes small things, they can cost you big amounts. And this is not just one example. You can find many other such examples on internet, and there are examples of such software errors which caused even human lives, many human lives, uh, resulting from the accidents that are caused due to such errors, such apparently small programming errors. So that's all for today. What we have done today, we saw what exceptions are. Mostly errors, they are classified as exceptions. When an exception occurs, program flow changes. If you allow Python to handle that exception, it will terminate your program and it will print some error messages. But you can always handle those exceptions, and you can save your programs for terminating abruptly. Instead, you can provide some other program flow to handle those exceptions. So that's all for today. Thank you.